All right, welcome. Today we're diving into something super important for Cardano, but it's one of those things that's kind of working in the background, totally invisible to most of us. It's called UTXO-HD. And honestly, it's the secret sauce that's going to let the network grow like crazy without, falling over. So let's jump right in. So how can success be your own worst enemy? It's a weird question, right? But for any blockchain that's doing well, the more people who use it, the more data gets created. And that mountain of data, well, it turns into a huge problem. If you don't solve it, it can actually threaten the entire network. Okay, to really get a handle on this, let's use a simple analogy. Just picture your Cardano node's memory. It's RAM. As a work desk, it's where all the action happens. It's super fast, perfect for what you're doing right now. But here's the catch. That desk space is limited, and it's expensive. And what's on that desk? Well, it's a massive, rowing mountain of paperwork. And this paperwork is absolutely essential. We call it the UTXO set. It's basically the master list of who owns what on Cardano. The problem is, with every single transaction, that mountain of paperwork gets bigger, and it's starting to completely take over the desk. So yeah, that brings us right to the heart of the matter, Cardano's growing pains. Or, sticking with our analogy, what happens when that desk just gets way too cluttered? So this paperwork has a technical name, of course. It's the UTXO set, and you really can think of it as the ultimate source of truth for the entire network. Every time a transaction happens, it uses up some old paperwork and creates new paperwork. And for the network to stay zippy and fast, this whole set has to be kept right there on that fast, expensive memory, our desk. And this chart, it just lays the problem out perfectly. Back in the early days, you see the paperwork was minimal, the desk had tons of space. Today, yeah, it's getting a little crowded. But look at the future projection. As Cardano keeps growing, the amount of RAM you need to run a node is just going to explode. It becomes massive. And this is where it gets really dangerous. Because if you need a super powerful, super expensive computer just to run a node, well, then fewer and fewer people can afford to do it. And that strikes right at the heart of decentralization. It's the whole point of a network like Cardano, and it would be at risk. Okay, so things were looking a little grim there. But thankfully, the brilliant engineers at IOG saw this train coming down the tracks a mile away. Their solution is called UTXO-HD, and you can think of it as giving our cluttered office a totally new, incredibly efficient filing system. And here's the real genius move. Instead of making every single node keep that entire mountain of paperwork on its pricey little desk, UTXO-HD does something smart. It moves the vast majority of it into a huge, much cheaper filing cabinet, which is just the computer's regular disk drive. Only the most recent stuff, the active work, stays on the desk. Now, this new system actually comes in two flavors, so node operators have a choice. The first one, V2 in memory, is kind of like just getting a better organized desk. It's faster, it's optimized, but it still keeps everything in RAM. The real game changer, though, is V1 LMDB. This is the true filing cabinet solution. It moves the data to the disk, which gives you maximum scalability for the long haul. So, you might be wondering, how does this thing actually work? How does it know what to keep on the desk and what to file away? Let's take a quick peek under the hood. Don't worry, we're not going to get lost in the weeds here. The key to the whole thing is this number, 2160. See, because of how Cardano's consensus protocol works, that's Ouroboros, the network has to be able to undo recent blocks, just in case there's a short-term disagreement on the chain. So the system waits for about 2160 blocks to pass before it considers something truly final and permanent. That means it keeps all the changes from the last 2160 blocks right there on the desk, in RAM, before it files them away for good. So here's what that looks like in action. A new block comes in, the node first checks its big filing cabinet on the disk. It pulls only the specific paperwork it needs for that block onto its RAM desk. Then, it applies all the new changes and keeps those changes in memory with all the other recent work. And then, as older blocks become permanent, it just flushes that old, confirmed work from the desk into the filing cabinet. It's just this constant, super efficient cycle. Okay, that's the theory, and it sounds awesome. But what does this actually mean for the folks who run the network? The stake pool operators, the developers? Let's go through a quick checklist for upgrading a node because the team really did put a lot of effort into making this a smooth process. Really, it all boiled down to three main steps. First, operators had to install a new library called LMDB. Simple enough. Second, they just had to update their configuration file to tell the node, hey, use this new system. And finally, they had to convert their old ledger snapshots into the new, more compact format. And part of that update was just, good housekeeping. All the new settings for this on-disk database were neatly grouped together into one single LedgerDB section in the config file. It's a small thing, but it just makes managing the whole setup a lot cleaner. And look, the official documentation could not have been more clear about this. It's just good practice, but it's always worth saying out loud. Before you do something major like this, back up your data. It's a simple step that can save you a world of hurt. This right here is a perfect example of smart planning. I mean, nobody wants to have to resync the entire blockchain from scratch. That can take forever. So to avoid that headache, the developers gave everyone a special tool, the snapshot converter, just to upgrade their existing data quickly. Super thoughtful. Okay, so we've looked at the problem and the really clever solution. Now let's just zoom all the way out and talk about the big picture. Why does an under-the-hood tweak like this matter so much for every single person who uses Cardano? At the end of the day, this is the payoff. It's a simple chain reaction. You lower the RAM requirements, that makes it cheaper to run a full node. When it's cheaper, more people from all over the world with all kinds of hardware can participate. And that directly strengthens decentralization. It's what ensures the network can survive and thrive for the long, long term. So really, UTXO-HD isn't just a technical fix for a memory problem. It's about a core promise. It's about making sure that Cardano can scale to handle global adoption without ever pricing out its own community. It's about keeping the network open for everyone. It just goes to show you, right? Some of the most critical work in this space happens behind the scenes. It's this quiet, foundational engineering that you might never even notice. And it really makes you wonder, what's the next invisible breakthrough being built right now that's going to secure our digital future?